Welcome! In this session, we will learn to calculate the correlation matrix, which will help us to identify variables that are highly correlated. And then we will use a qualitative analysis to determine if we must eliminate irrelevant variables that could generate multicollinearity in our model. So let's start, and we are going to compute the correlation matrix. We are going to create the variable correlation, and we will use the function core. And as a parameter, we will use our credit cards data frame. We press enter, and now we have computed the correlation matrix. We double click on correlation, and now we have to look for those variables that have a correlation greater than 0.4 or less than minus 0.4, which are candidates to be eliminated. But this elimination should be decided by a qualitative analysis. That is, if it makes sense to eliminate the variables. So we will look for those variables with a correlation higher or lower than 0.4 or minus 0.4. Obviously, I have done this already, and I know that there are two pairs of variables. The first one is the time of employment and the down payment fraction. And you could see here that they have a negative correlation of minus 0.56. And then we should look on the dependent variables, the correlation of these two variables, and you will see that it's quite high. At least when you compare the correlation of these variables with the dependent variables, you will see that it is 0.15, almost 0.16, and minus 0.13. And you will see that the others correlation are 0.2, 0.5, 0.1, 0.3, 0.4. So actually those two variables are quite relevant for the model. So we should now see if there is a qualitative reason why these variables are correlated. So if one depends on the other. And at least for me, it's difficult to think in one reason why someone which has a high time of employment will provide a down fraction of a down payment fraction. So at least for me, I cannot think on a reason. And I will decide to keep these two variables in my model, at least in my preliminary model. Then I will see if I will decide to keep them or to throw at least one of them. But at least in my preliminary model, I will include both of these two variables. The other pair of variables which are highly correlated are region and branch. You could see here that they have a strong correlation of 0.76. In this case, they are not so correlated with the dependent variable. You can see here 0.017 and 0.03 for branch. So they are not as important as the previous variables that we saw before, the time of employment and the down payment fraction. So probably we should decide to throw at least one of these two variables. And if we do a qualitative analysis of the relationship between region and branch, it is quite obvious. There are several branches in one region, or at least one branch for each region, and there could be one or more branches for each region. So there is a reason why these two variables are strong correlated. What should we do in this case? Well, we should keep just one of them, but we should try that when we train our model. Probably a strong candidate will be branch because it has the higher correlation, but we should try also with region. And that's what we are going to do in the following sessions. Thanks for watching.